Okay, good morning, everyone. This is Walker from MakeBlog. Thanks for Olivia's introduction to the 2024 challenge competition rules. And next, I'm going to introduce the technical parts of challenge. Let's begin. This training contains 4 parts: introduction to the core electronic parts, and tank design ideas. Tank refers to robot, and basic algorithm design and structure design analysis. So first, let's have a look at what core electronic components are needed in the challenge. The first module I want to introduce is the lower Pi. Lower Pi is the essential motherboard for building challenge robot. It has those features. It supports MakeBlog mental parts and log pins, and it's applicable to main control boards such as Holocode and SafePi. It has 5 on-board interface and 6 smart motor interface, and it's on board 6-axis motion sensor, and it supports power expansion board and small size, and it has a high performance processor. This is a variant diagram of lower Pi. You can see there are many different interface and power port and universal interface and so on. And next one is lower Pi power extension board. This board is equipped with an RAM Cortex M4 core MCU. It can control DC motors, mechanical clocks, solenoid valves, and brushless motors and other power devices. So it's very powerful. And this board is very easy to install. You only need to align the interface here and insert it into the top of the lower Pi. And the lower Pi power management module. It's a necessary electronic part in challenge competition. It's wirelessly connected to the MakeX computation system to control the power of robots and send the commands to the robots. Here is the interface diagram and a simple program. Usually we use this program to let the robot switch between automatic stage and manual stage. "180 smart encoder motor. It's an entry-level and built encoder motor. It works with lower Pi to serve as a chassis motor for challenge. And you can see the parameters and the some features here. And how to use the serve in the program? Look here. We can specify the power and the speed and the angle of the motor, and we can also read the motor's current angle and speed. This is blocks in MakeBlog 5. "37 DC motor. It's the most common used motors in the MakeBlog platform. It's compatible with multiple main control boards of MakeBlog platform such as MakePi, MakePi Pro, and MiOriga, and lower Pi. There are these motor features. The speed can be changed, but the position and the speed cannot be precisely controlled. And the output torque is large and can withstand certain overloads. and it can test both clockwise and anti-clockwise. And it supports Arduino library for easy programming, and also support MBOOK 5 and support Raspberry Pi Python programming. And the hosts are compatible with MakeBlock structure parts. These are the tech specs and the use of the program blocks. We can see there are two models to meet different needs. These two, and this one is stronger in all aspects. Yeah, this is a sample program for the use of the 37 DC motors. And first, after entering the main function and enter the loop, and we specify the DC motor to rotate with power 100%, and waiting for 5 seconds and stops, and then waiting for another 5 seconds. The circle is ends. Circle ends. Yeah. And next one is the smart servo, MS12A. It's a new generation of smart servo independently developed by MakeBlock. It focus it focuses on solving the problems of traditional servers, such as complex control and small angle range, and inability to rotate continuously, and so on. This is a symbol diagram and how to install a smart server. And some precautions for this one when we use it, and how to use it in the program. Uh, we can specify the service number and power and angle and speed. And we can also read the current voltage, speed, angle, and even the temperature. This is a simple program for using smart servo. Brushless DC motor is designed to provide power for catapults. It can rotate at a speed much higher than other DC motor, and that can be used to shorten structure in challenge robot. You can see the speed is up to 7,300 RPM, so it's very fast. And the blocks. Okay, after understanding the above mentioned electronic parts, let's think about how to design the robot. First, we have to analyze the computation tasks. In auto stage, we can scribble resources and log out the pin and short the disks into the smelter. And in manual stage, except for the missing 1, 2, 3, we can also hit the reversal flag. And in failure stage, we can complete all tasks, including hanging team flag. So there are 5 missions. Shorting discs into the smelter. The robot on both sides can collect the colored discs and short them into the smelter pod and then enter the center smelter. And the MakeX challenge. In this mission, we can collect and place the 5 airboard cube MAKE and X in order from top to bottom. And hitting the reversal flag, the robots on both sides can collect the discs and shoot them to hit the reverse flag and causing the flag to lead towards to the opponent. And the last one, hanging team flag. The robot can hang its own team flag on the flagpole in the flag hanging area. And the robot can only carry one flag into the arena in a single game. Then once we have a clear understanding of the tasks, we can think of the robot need some structure like clip structure to clip the disks and connect structure to storage and short structure to emit the disks and the hand structure to hand flag and lift structure. And we also need a common device to transfer the disks and basic chassis structure. The size of the robot is no more than 15 by 15 by 17 centimeters, and there are some points we need to think carefully about these structures. One, try to modularize the design and think carefully about the installation and reserve connection holes and perform functional testing before installation. Like this, this structure designs are necessary. Contains four main structure. And it was mentioning that the Bluetooth motor and the smart servo are necessary in shorting structure. Then next, let's see how these structures can be achieved and what parts are we need. There are some mental structure parts we commonly use, like gear structure, for acceleration and sliding beam for transport. And shifts and tools. They can be used to support and position rotating parts and transmit torque, change the direction of shifts, and so on. And they can also be used with other components such as gear and fixed ponies. Chassis movement. Chassis movement is a basic structure in challenge. And in terms of wheel selection for chassis, we began to use MakeX wheel to replace the previous only wheel. The advantage of the MakeX wheel is when move in diagonal directions such as left front or right front, it will be faster and more stable. That's because of the spatial design. You can see here there are many small rollers around the entire wheel that rotate in different directions, and this design maintains the same height and avoid vibration. It also ensures that the robot can move in parallel directions. And clap structure. Clap structure can be designed as double clap or single clap. Double clap has a wider angle, but it requires at least two servos. And convey structure. We usually build it through track and get rails. The motor drives the wheel to rotate, and the tracks or get rails drive the discs transport for transportation. Like this. And here are 4 different designs with track and get rail. So you can, when you build your own robot, you can choose one of these 4. And leaflet structure, usually we build leaflet structure with belt and sliding beams and wheels and motors. And connection structure, like this. Okay, shooting structure. Shooting structure is very important. The shooting structure contains a brushless motor and 1 or 2 friction wheels. Here, this is this is 2 friction wheels, and this is 1. Two friction wheels can shoot the discs in a straight line. And this one is a upgraded version with stronger force and more stability. Because the contact area is larger than before, and the friction is stronger. So then we go to part 4. We will analyze the basic chassis algorithm. This is the most basic rectangle building structure. And because of the spatial design of the MakeX wheel, when moving forward or backward, each wheel will receive the force in 2 directions. For example, this one will receive the forward and right 2 direction speed when the robot moving forward, and it's the others wheels. This direction and this like this, yeah. And when the same goes to the when backward. So we can set the we can build the program in software like this. We only need to set the power of the 4 motors to be the same, and it will move forward and backward. And this is a program for moving left and right. Motor 1 and motor 4 are in different directions. And if you want the robot to move left from 45 degree. You only need to power these two wheels. And the same goes for the right front. And this is for clockwise rotation and anti-clockwise rotation. You can see every wheel's direction like this. Okay, so this is the chassis algorithm analysis. Okay, that's all my introduction for the challenge technical competition. So if you have any questions or any questions you want?
I
Okay.
understand. Hi, this is Asep from Malaysia, Walker. I understand that the challenge control box will be updated this year.
Challenge control box.
Yeah, the box that you use to display the score and timing during competition.
Yes, maybe we will upgrade it in the next sorry, in the next half year.
Okay. So is it still compatible with the previous year
Yes, most
electronics?
parts are compatible, but we will change some parts or electronic parts.
So you will change some electronic parts in the MakeX challenge robot.
这个什么，就是那个
My question is basically, can we use the previous electronics for this new control box? Previous year electronics like Nova Pi, the communication card, the Bluetooth one.
Yes. Some main electronic parts we don't change, like Nova Pi and some motors and servos we won't change. Yeah, you can use it.
Okay, okay. So no need to buy a new parts. Yeah.
Upgrade upgrade box.
Yeah.
Yes,
Okay. Thank you.
you're welcome. And any questions for others? When did you get the forward and backward block? You define number one. Yes, you have to identify it by yourselves in make block 5. Is it allowed to add extension? What extension you are refer? Yes, you can add extension in make block only if your program is built in M block 5. It's allowed.
Any other questions? Okay, so so here is the end of the training of this morning, and so let's take a lunch break, and we will see you at 2 p.m. China time. Okay, thank you for your time. Bye bye. See you.
Thank you.
Thank you. Bye.
Thank you. Bye bye.
Karina, thank you, Olivia. Bye.